Hello, this is section 3.1, where we have now entered into chapter 3, the last chapter that we'll be covering on our test. And the good news is that this should be a little more digestible based on our previous general chemistry knowledge, because this chapter covers a lot more about acids and bases and how we deal with those in organic chemistry. So just in case you are in need of a brief refresher on what an acid or a base is, specifically a Bronsted acid or base or a Lewis acid or base, then we're going to cover that here right now. So a Bronsted, whoops, a Bronsted acid or base is what we'll cover first. So in this reaction, let's see, let's do like the reaction that makes volcanoes happen, or at least science experiment volcanoes happen. So if we take acetic acid and we add to this sodium bicarbonate, what we get is some equilibrium between this oxygen taking a hydrogen, leaving us with sodium acetate, and carbonic acid. I forgot this was lone pairs. There we are. There we are. And a fun little aside is that once you have carbonic acid here, depending on the pH, it very quickly decomposes to give you CO2 gas and water. And the CO2 gas is actually what makes the kind of foaming, crazy reaction that you're so often used to seeing with those volcanoes, because the gas evolution causes it to get all foamy. So in this reaction, where we make a volcano, there is an acid and there is a base. The acid is the molecule that loses a proton. And the language here I'm using is loses, but sometimes you could also say the one that gives a proton. Either way. Okay. And bases, let's do this in a different color. Bases, according to the Bronsted definition, are the ones, the chemicals in a reaction that obtain a proton or takes a proton. Either ways of saying it are factual. Okay, so this is basically what an acid and a base are in Bronsted terms. But in Lewis terms, like such as a Lewis acid or a Lewis base, we have a slightly different scenario. Let's use green. So Lewis acids or bases talk about electron donors instead of protons. So here the acid was the proton donor, right? Loses a proton, donor, and acceptor. Here, the acid in the Lewis acid, electron pair acceptor. While the Lewis base is an electron pair donor. Okay. The acid gives electron, or the acid in Lewis terms takes electrons, and the base gives electrons. Okay, so this could kind of be shown really easily by the following reaction, like this, where you have maybe some kind of phosphorus. Yeah, we'll say it's like a phosphorus like this. Phosphorus has a lone pair, and when it attracts something like a boron, maybe a boron with 3 fluorides, it will attack the boron to give us this molecule. So here, the Lewis acid is the BF3, and the Lewis base is the phosphorus. So this has been section 3.1.